Hello everyone, this session is about polyamines. What do you mean by polyamines? An amino acid containing more than one nitrogen compound, it is called as polyamines. In our body, we can see three important polyamines. They are putrescine, spermidine and spermine. So they contain multiple amino groups. So how we can synthesize polyamines in our body? First thing, S-adenosyl methionine is decarboxylated, okay, to form decarboxylated S-adenosyl methionine. The second substrate is ornithine. Ornithine, when it is decarboxylated, you can see here. So when it is decarboxylated, this is going to give the first polyamine, that is putrescine. Next, what happens? We have to synthesize spermidine and spermine. This putrescine combines with the decarboxylated S-adenosyl methionine. So the first reaction is decarboxylation reaction. So the enzyme is decarboxylate. Second thing, putrescine combines with the decarboxylated S-adenosyl methionine to form spermidine. Okay, so the enzyme here is spermidine synthase. Next, what happens? The spermidine once again combines with decarboxylated S-adenosyl methionine to form the last compound, that is spermine. So the enzyme here is spermine synthase. So this is the overall synthesis of polyamines. So we have got putrescine, spermidine and spermine. Next, I've said the polyamines contains multiple amino groups. You can see here, putrescine contains 2, spermidine contains 3 amino, spermine contains 1, 2, 3 and 4. If it contains more and more amino groups, they are positively charged. So they can be attracted to the DNA and RNA. So more often they bind with DNA and RNA. What are the functions of polyamines? They can synthesize protein, DNA and RNA, and it helps in cell growth and proliferation. One of the important factors is it acts as growth factors. So in tumor cells, you can encounter more and more amount of polyamines. So all your tumors have elevated polyamines level. So how it helps in protein biosynthesis? By producing hippusine. Actually, your initiation factor 5A is inactive. It contains lysine residues. To make it active, we have to add butylamine moiety of the spermidine group. Okay. See, you have added the butylamine moiety of the spermidine here. Next, what you have to do, you have to add the hydroxyl group to this lysine. So the first thing, you have formed deoxyhippusine. This is an intermediate compound by adding the butylamine moiety. Okay, so you have oxidized using this one, deoxyhippusine synthase. Next, what you are doing, you are adding hydroxyl group. This is the original hippusine compound which is active. Okay, you are adding hydroxyl group, so the enzyme is hydroxylase. The intermediate is deoxyhippusine, so the enzyme is hippusine synthase. Last thing, you are adding hydroxyl group, the enzyme is deoxyhippusine hydroxylase. This hippusine helps in initiating, okay. So when the hippusine moiety is formed, your initiation factor 5A is active. So it helps in protein biosynthesis.